All right, so I've been having a lot of fun with CAD Sketcher, and I think I know a little bit more on how to use it. So I'm going to be trying again with this shape I got here. So at first, what I want to do is create a sketch, and this way you can select a plane to work with. And I like to work on the floor plane, which is defined by X and Y axis. So now we are inside this sketch plane, and we can start doing the outer shape. So I'll just freehand it for now. Maybe I can start with a line, and also it's important to figure out um, which is going to be the center of the drawing. So in this case, I think right in the middle of the circle, this will be the center of the sketch. So I'm just freehanding a line here, and as I discovered last time, if I sort of draw a vertical line, it automatically gets a vertical constraint, which makes it perfectly vertical. So that's pretty cool. And now let's see another one here for symmetry. And escape will escape the current tool. And if I press escape again, we go to the select and move tool. Oh, let's see. We have this, which should cross the midpoint, and again, like so. And then the curve parts. But when I tried the first time, yeah, I see it now. I think basically I made a mistake because these curves, these are two opposing curves, and the solve was giving me a shape here that went back a little bit like this and then back down. So in the case of the drawing, this doesn't happen. So it actually stays flat for a little while and then just keeps going down. So for that, we're gonna draw an extra segment this time, and it should work. Um, let's start with the arcs. So like this. And now the line, tiny line over here. And we continue with another arc, like this. And now let's draw the opposing side. I wish we had some sort of mirroring operations or so, but I don't think that's possible as of now. And for this arc, I think I need to go start inside and then draw the arc. And that's it. So the only missing thing is to connect. And we can do this by adding a 2D line, but also we can actually select the 2 points and hit L for line, I would say. And this creates the segment, the missing segment. Now this is everything, but now we gotta start. Uh-oh, I sort of screwed up. Yeah. So this is everything I need, and now I just need to start adding the constraints to solve this external part of the drawing. So here I somehow lost the the vertical constraint. Let's just add that back. And let's start adding some measurements. So we have these ones. The easy ones are this, which is a 30. Yeah. Now I'm not sure about the scale of this yet. So once we put the first measurement, everything will make sense or not. So in this case, this is 2.7 meters tall, and that's not a lot, right? So I have a choice here. Oh, I cannot select this to move it now. Yeah, I wish I could move this, but I can't. So I have a choice now. I could simply divide everything by 10. So instead of 30, I can just use 3, which I think I'll do because I don't want a 30-meter piece. So let's just, ah, I said 3. It's gonna be a slightly confusing, but should be okay. So this is 30, and I believe at the other side, there's also a 30 here, which I can actually do with an equal constraint. So this and this element should be equal, and now they are. Okay, I have other measurements like this one. This one should be 20, and in my case, it should be 2 meters. So the distance constraint is done between 2 points. So I'll just click on it to type exactly 2 meters. And again, this and this should be equal. So that's easy to do with an equal constraint. This angle isn't measured, so it's gotta be figured out by the solver. What else? What else do we have? So we have some radiuses or radii. I don't know how to say the plural of radius in English. Um, but let's just add the radius of 15. So in my case, the radius should be 1.5 for this curve segment. Uh, the um, the sketcher doesn't have a radius constraint, but it has a diameter constraint. So of course, diameter should instead be 3, which makes for a radius of 1.5, like this. And the equal constraint, when it's applied to circles or arcs, will equalize the diameter, which is exactly what I need here. So let me just freehand this, put it somewhere else. Uh, hmm, right, I think we need more space in here. Yes, like this sort of. And of course, the sketcher is only allowing me to move what is not yet constrained, right? So let's add back the horizontal constraint here. Sometimes you delete them by accident. This is something that I think it would be best to remove this. Like you would need to select the constraint and then delete it, because sometimes I just hit it by mistake and I just deleted it. So yeah, I'm no expert, but it's my humble opinion for the developers. Maybe make deleting constraints a little bit more not so easy to do by mistake. All right, so what else? We have this radius of 10, which in my case means it should have a diameter of 2. So let's diameter constraint this guy to 2, and then make these arcs equal. That's good. Also, we have a measurement here of 50 between this point and this point. That's an easy one to do. So this point and this point have a distance of 50 or 5 in my case. Okay. Oh, see there, I actually just deleted a horizontal constraint by mistake. So that's a little bit annoying. Okay, so what else can I do? Well, I have a distance. I have a distance of 2 meters over here, which is already fine. But the other distances are 30 between this corner and the end of the drawing here. And also, we know that from the midpoint and to each side we have a 40, distance of 40. That's interesting. I do not want to over constrain this drawing though. So I'm being very careful on where I add a new constraint because the idea is that just to add enough constraints so that the solver figures out the rest. So not adding too many of them if they are not needed. Um, and right now I'm at the point of being really careful about this. So for example, yeah, I think I'm gonna add this 3 meter constraint, distance constraint over here. So to do this, I've found that in this implementation, the distance constraint is always between 2 points, and it cannot measure vertical or horizontal distances. It will always be in the exact angle that defined by the 2 points. So in this case, if I add a distance constraint between this and this point, it will uh, define this distance, which is something that I don't want right now. So what I have to do actually is create a couple of construction lines. So I think something like this, and mark this line as a construction line. And now I think I need to add a second construction line over here just to make this vertical. And let's mark this guy also as a construction line. And now I can actually measure this um, horizontal distance of 3.0. So let's do that. Distance between this and this point should be 3. This makes quite a difference actually. So that's good. That's good. Let's also make this line and this line equal because they should be. And I think I'll start formatting things so with more construction lines. So for example, I need to draw a line maybe over here just to make sure that, well, I cannot draw it. What's going on here? Or maybe over here. It shouldn't matter. Um, right. See, I keep deleting things I'm not supposed to delete. Okay, like so. So this line just made sure that the drawing is completely straight. And now I can make it a construction line too. All right. Yeah. Okay, so I have another measurement here that will help. Between this point and this point, there is a distance of 5.0. Okay, that's already done. But this one should be 3.0. That's already done. Okay. So what's missing over here? So let's add the tangent constraints. The tangent constraints make sure that the join or the joint between a curve and another curve or a curve and a segment are completely smooth, so not like a broken, um, like here, for example. Here it is a bit broken, and as soon as I do, so as soon as I add a tangent constraint from here to here, it becomes completely smooth, and I can do the same here and here. And whoa, what's going on here? Oh no. Let's do it again. So tangent between this and this. Why isn't it working? Hmm. This works though. Maybe it's just over constraining. That's the problem. If I over constrain things, I'm gonna get into trouble. Here, I think we should add a tangent constraint too. Here and here. Yeah, that helps a lot. Right, so I like to just move some points to see what is still unconstrained. Because you see, I should be able to add a constraint between this curve and this line segment. So I'm gonna try again, but I'm gonna save first. So tangent between this and this. Why? There you go. Now it did it. It's probably just an UI issue, I guess. Okay. So I think I'm missing a distance here. Yes, so let's see. Right, there's an 80 distance. Um, it's a little bit hard to read, maybe some anti-alias issue here, but there's an 80 distance between the far top and bottom points. So let's do that. It should be pretty easy to handle, like so. So 8, that's a good measurement right there. And what else? Let's make this completely vertical by actually drawing a line between these points. And it automatically gets a vertical constraint, and let's just mark it as construction. So now the drawing is completely vertical, and we have only 5 degrees of freedom left. So not too bad. Yeah. What other measurement can I add? So I think I'm gonna need, I actually want, hmm, I think that it's mostly the horizontal measurements that are completely missing right now because I have this measurement, but I don't have the full measurement. And if I add a full measurement, I should be able to improve dramatically. So well, 40 plus 40, that's 80, right? So this is a square drawing. Let's just add between this point and this point. Let's add a distance constraint, like so, and just like that, 8 meters. And I probably have to make this also completely horizontal. But that took the degrees of freedom down to 4, which is, well, better. Not quite fixed yet, or not quite solved yet. And I think that's it apart from centering the drawing vertically. Also, this thing, I don't know. I don't know how long is this tiny segment over here, or if it should be calculated out. Maybe it's just calculated automatically. Let's not define it yet and see if the system figures it out. And let's force this thing to be completely yeah, horizontal. So another construction line, I guess. There's probably better ways to do this, but I don't know. So now our drawing is down to 3 degrees of freedom, which is not bad. All right. And how can I center this guy? So I think I can add, let me try and do something. So if I select, if I make this guy's midpoint, select the point and then the line, this is actually a nice trick. So another midpoint constraint from this point to the line. Oh, that's, yeah, it didn't like that one, but maybe I can make it coincident. That's better. So yeah, this is how constraints actually can collide with each other. So I have to decide how to do it. So for example, if I want to do 2 midpoints like this and this, now this horizontal constraint is redundant. So if I delete the horizontal constraint, now both can get to the midpoint without the horizontal also trying to say where those points are positioned. So that's what happens, and you have to keep track of your constraints and your and your drawing in general, and try and use as little or as less is better, because you have to keep track of them. So now we're still at 3 degrees of freedom, which is fine because I now have this guy, which I can also set as construction. So this guy, I can create another midpoint relationship between this line and a point. And this will center our drawing completely. So between this and this. There you go. So this was the key. So now our drawing is completely centered, and we are down to only 1 degree of freedom. So there's only one thing that I can like mess up by hand, and is not defined by a parameter. Let's find it. I think I got it now. So how do I do this? Um, yeah, I think I should center this guy too, I guess. There are two ways. I could, let's see, what can I make equal or so this is another thing I've learned recently. So for example, I could say if I make these lines equal length, then the drawing should center itself, and that's true, but sometimes things are harder to figure out for the solver. So if you can make it easier for the solver, sometimes that's better. So what I'm gonna do is just create another line, another construction line over here. This guy is completely horizontal. I'm gonna make it a construction line, and I'm gonna create a uh, let's try another midpoint. And just by doing that, you can see that my sketch is fully defined, which means I can no longer mess around with anything except the parameters. And the great part about this is that I didn't actually have to know the dimension of this line. As you see, it's not defined anywhere. So the solver figures out how long this line has to be for everything else to match. And that's the beauty of this type of CAD systems. I just love this. So let me save, and we are gonna attempt to do the rest. I had to switch microphones in an emergency. I hope things were working up to about right now, but I can't be sure. So let me just get rid of this microphone and keep using this one. Okay. So, yeah, this is beautiful. Let's just save and draw these circles. The first one should be constrained right in the middle. And to do that, and this is something I had trouble before, but now I know how to do it. So when you draw an arc or a circle, the first thing that you do is to select the center of this primitive. So in this case, I'm going to use the existing point in the or the middle point as the center of the circle. So this means that the circle is already constrained to the center of the sketch, and we only have 1 degree of freedom, which is the radius. That is just fantastic, because we don't have to take care of centering this circle any longer. This has a value 40 here. I don't know what this means, honestly. Why here it says radius and here? I guess it's because this is an arc, so the nomenclatures are different, or I don't know. I'm not an architect or engineer whatsoever, so let's just add a diameter here and try and match what's in the drawing. It's gonna be hard to, okay, so let's try 4. Yeah, I believe that's it. Diameter of, why though? This is now a diameter. So this is a little bit confusing, and it's probably something I just don't understand about reading this this thing. But now, well, this is apparently a diameter, and if we convert to Bezier and leave the sketch, we can check that everything is working nicely. This circle is now a hole in the drawing. So let's save and go back to edit the sketch and add the remaining 2 circles. I mean, 5 circles actually. So this is something I've just tried and it works. So I created the circle over this line, and apparently this, no, it doesn't actually work. Okay, or I deleted it. I don't know. So let's see how we can do this. This should be in, should this be in the middle, or? Ah, there you go. There you go. Okay, this measurement is 60. Oh, let's figure this out. I could try and use a coincident relationship between this and this. Yep, that's good. And this makes it so that the circle actually slides over this line, which is perfect. And let's just add another one. Hopefully, if I create the second circle with this element highlighted, the coincident constraint is already added, as you see. The trick is not deleting it, because deleting constraint is too easy right now. But yeah, there is the coincident constraint, and I can actually set the distance constraint of this between these 2 midpoints to 60, which is or 6 meters. Oh, let's see, 6 meters. Yeah, there's also another bug. It's hard to highlight these quotations sometimes. Maybe if I do this, I don't know. Probably a few books still in the add-on, right?
it's hard to just highlight this to move the distance constraint UI to one of the sides. So we are still at 3 degrees of freedom, obviously. This guy has 10 diameter value, so let's just do that. And that should be 1 meter for us, and make these two circles equal. So now we're back to 1 degree of freedom, and it's probably they can both slide because they are not centered yet. So if I do this, yeah, I will be able to slide them. But let me leave it like that just for now and save again. And let's create this guy. And I'm gonna also use the coincident constraint created automatically. So if you see this icon, this is the coincident constraint that it has been created automatically, which is so cool. And let's make this diameter equal to this. And now we have 2 degrees of freedom, which is both of these guys sliding. Uh-oh, what did I do? Yeah, both of these guys still sliding, and this guy is also sliding over here, but we'll fix that in a little bit. And the last two, these ones are actually pretty easy because these circles can use the same midpoint as this radius. So all I have to do is go and create the circles. Oh no, well, it could, right. It could be a little bit annoying if the constraint gets in the way, but there are workarounds for this. So what I'm gonna have to do is delete this for now, add the two circles, right? And here too, right? And then let's add the missing equal constraints for the diameter. Okay, and now we just have to get this radius back. So yes, so this radius has to be constrained, but that's easy now. It was a diameter of 2, if I recall correctly. Oh no, there you go. I just need to set it. This needs to be fixed. Okay, so diameter of 2. We are so close now. I think I just need to center these guys and center these guys. So this one should be easy. Let's see, how can I center this though? All right, so this one is easy. This is a distance of 10 from the edge. So 1 meter from the edge. That's easy though. So let's do that by adding just the distance. Yeah. So we already have this point. So let's measure this distance and type a 1 over there. And now we are only missing 1 degree of freedom, which is the sliding of this 2. And how can I center this 2 without creating too many construction lines? Construction lines are important because if I didn't mark this as construction lines when I create or convert the drawing to some type of geometry, this would interfere, and I want them gone when I leave the sketch and convert it to geometry. So it's super important to mark them as construction so that they do not participate on the final geometry shape. And now, how can I center this too? I guess I'm gonna have to create a couple of construction lines. So yeah, I mean, if I can handle like an equal constraint between two lines, that's pretty much it. So let's just do that. It's a bit messy though, but oh well. Oh no, it's gonna be hard to do because things get in the way. And oh man, we were doing so well. So another way to no, yeah, like if I select this two and hit L, that's a nice trick when things get in the way. So I'll just use the L for. Oh no, and this guy is also gonna. So I have to actually delete this constraint for a second. So it's 1 meter. Let's delete this constraint. Add a new line segment over here. L. And then I have to mark. If I could. I need to make these two equal. Nope. Let's go. Let's roll this back. Oh no. We are so close. This is stupid. How can I do this? This is just, I mean, it's no problem. It's just UI, you know. But it makes things a little bit hard for now. Midpoint ratio. Yeah, okay, this is gonna be ugly. And what I'm gonna do is create lines like this, which is not ideal, just for the purpose of making them equal and centering this thing. So this should be a construction line, and this should be a construction line, and this should be equal. That should take care of the centering, and the only missing degree of freedom is the diameter of this, which actually drives all of the circles, tiny circles diameters. So if I do this, all of them update, right? So that means if I, again, set the diameter to 1, I'm done. Again, I have the fully defined sketch over here. And this should be a pretty much perfect copy of this. Entirely driven by parameters, which is fantastic. This is the power of the new parametric design in CAD Sketcher. So let's leave this sketch with convert to Bezier. And we have this. And now we can play around with the curve, because this is actually a Bezier curve, right? So I can actually see the drawing if I enable this, or enter again to do some change in the parameters. But for now, I'm just gonna select the object and do some geometry manipulations, like for example, an extrude, like this, and maybe a bevel, tiny bevel over there. So maybe 0.1 with a higher resolution. And we have this beautiful parametric shape. Yeah, something I don't like about curves in Blender is that they are beveling and they are changing the internal dimensions. We're gonna have to ask about this and see if this can be changed, because Yeah, this makes the dimensions not work anymore. But yeah, that is something to ask the developers. But anyway, this is quite beautiful because it is completely non-destructive. I can go back to the sketch and change things around. If I change this diameter to, let's change something different. Like for example, let's see if I can change this from 5 to 4 meters. No, this actually breaks the drawing though. What can I change without things completely destroying themselves? Maybe this? 1.5. Yeah. So see how interesting this is. It was originally at 2 degrees, and this angle is actually figured out by the solver. And if I change it to 1 meter, then the solver has to change this line and make it more pointy in order to match all the other measurements. So that is the power of parametric design. All right.